Your car is deliberately holding back power right now. Not because it is worn out, not because it needs new parts, because the computer running your engine has been slowly, quietly, and intentionally trained to be lazy. And the dealership that charges you $150 to fix it is counting on you never finding out why. Every time you pull out of a parking lot and the throttle feels mushy, every time you press the gas to merge on the highway and the engine hesitates for that half second too long, every time your fuel economy is just a little worse than it used to be, that is not age. That is software. That is a process called adaptive learning, running in the background of your engine control unit, building a profile of your driving habits and slowly dulling your car's response to protect emissions numbers. And the 60-second sequence that clears it completely, the one that restores your throttle to its original factory calibration, costs absolutely $0 and requires zero tools. Japanese fleet mechanics have been doing it as standard maintenance for decades. Western dealerships have been charging for it as a premium diagnostic service for just as long. Today, that ends. To understand why this works, you need to understand what happened to your gas pedal in the early 2000s. For most of automotive history, the connection between your foot and your engine was physical. A steel cable ran from the pedal under your dashboard, through the firewall, and directly to the throttle body sitting on top of your engine. When you pressed down, the cable pulled, the throttle plate opened, and the engine responded instantly and completely. There was no interpretation. There was no delay. Your foot was the engine. 1 inch of pedal travel meant 1 inch of throttle opening, every single time with zero lag. Then, the emissions regulations tightened. Engineers were told to reduce hydrocarbons, cut nitrogen oxides, and hit fuel economy targets that a purely mechanical system could not reliably achieve. The solution was to remove the cable entirely and replace it with electronics. This is the system called drive-by-wire, and it is now standard on virtually every car, truck, and SUV built after the year 2003. Under drive-by-wire, your accelerator pedal is no longer connected to anything mechanical. It is a sensor. When you press it, it sends an electrical signal to the engine control unit, the ECU, which reads that signal alongside data from the oxygen sensors, the mass airflow sensor, the throttle position sensor, the vehicle speed sensor, and a dozen others, runs all of that through its programming, and then decides how far to open the throttle. Not how far you asked it to open. How far it thinks it should open, given everything it knows. At first, the response is close enough to mechanical that most drivers never notice the difference. The factory calibration is tuned to feel quick and responsive. The engineers know that a sluggish new car does not sell. So, off the lot, the ECU is running its base map, clean and sharp. But buried inside that same software is a feature that the factory documentation calls adaptive fuel and throttle control. And what it does, over time, is rewrite that sharp calibration based on observed behavior. The ECU runs continuously. It watches everything. It logs every cold start, every idle, every time you sit in a school zone at 15 miles per hour with your foot barely touching the pedal. It logs every time you crawl through stop-and-go traffic for 40 minutes. And over thousands of miles, it uses all of that log data to build a model of how you drive and adjust its own parameters to match. In engineering terms, this is called long-term fuel trim adaptation combined with electronic throttle control learning. In practical terms, it means the computer gradually softens the relationship between your pedal position and the throttle opening. It adds delay. It smooths the response curve. It prioritizes the emissions profile it has learned from your real-world driving over the responsive calibration it left the factory with. The result, by the time most vehicles have 40 or 50,000 miles on them, is a car that feels noticeably slower and less responsive than it did when it was new, even with no mechanical wear whatsoever. This is not a defect. It is a feature. The engineers designed it this way intentionally. The adaptive learning system genuinely does improve emissions performance and fuel economy in most real-world driving conditions. The problem is that it does so at the cost of performance, and it has no mechanism to reset itself. Once the learned data accumulates, it stays accumulated. The ECU does not wipe its own memory when you hit the next service interval. It just keeps learning, keeps adapting, keeps softening, unless you force it to stop. That is where the dealership enters the picture and where the real money is made. When enough drivers start noticing that their cars feel slow, they bring them in. The service advisor hears the complaint: throttle lag, hesitation, loss of power, maybe a slight drop in fuel economy. He nods, writes up the ticket, hooks a scan tool to the OBD2 port under the dashboard, navigates to the ECU reset function in the software menu, clears the adaptive learning tables, and disconnects the tool. The whole process takes under 2 minutes. He then writes on the invoice, electronic throttle body adaptation and ECU recalibration, $150. Sometimes $200. The customer picks up the car, feels the immediate difference, and assumes that something complex and technical was done to their vehicle. Nothing was. The computer was told to forget what it learned. That is the entire service. The reason this stays secret is not conspiracy. It is incentive. There is no reason for a service advisor to explain that the fix is free and takes 60 seconds. There is every reason to make it sound like software engineering. And because most car owners have no idea that their ECU even has an adaptive learning function, let alone that it has a manual reset protocol built into the factory firmware, the explanation is never questioned. Now, here is where the taxi fleets come in, because this is the evidence that proves the reset is real and that it works. The Toyota Crown Comfort is a purpose-built taxi platform that has dominated Japanese urban fleets for decades. These vehicles run 12, 14, sometimes 16 hours a day in the most punishing stop-and-go conditions imaginable, in Tokyo, Osaka, and every major Japanese city. They routinely reach 500,000 kilometers on original engines. They do not feel sluggish after 50,000. They do not lose throttle response after 100,000. And the mechanics who service them do not use expensive scan tools to keep them sharp. As a mandatory item in their scheduled maintenance, Japanese fleet garages perform what they call a manual ECU initialization sequence every 10,000 kilometers. It is listed in their internal service documentation alongside oil changes and filter replacements. It takes less than 2 minutes, requires no equipment, and costs nothing. The result is an engine that continues to respond like new throughout the entire service life of the vehicle, because the adaptive learning data never has a chance to accumulate past a certain point. The fleet data supports this completely. Vehicles maintained on this schedule show measurably faster throttle plate response and statistically better fuel economy than comparable vehicles that rely on scan tool resets at dealership intervals. The sequence they use is not proprietary. It is not exclusive to Toyota. It is built into the firmware architecture of every modern drive-by-wire vehicle as a diagnostic and initialization routine. And you can perform it yourself, right now, in your own driveway. Here is the exact procedure. Read it through completely before you begin so that the timing is clear in your mind. Get into your vehicle and close all the doors. Make sure the air conditioning and all accessories are off. Do not press the brake pedal at any point during the initial sequence. If your car has a traditional key, insert it and turn to the on position, one click before the engine cranks. All dashboard warning lights should illuminate. If your car has a push-button start, press the start button twice without touching the brake pedal. The dash lights will come on without the engine starting. You are now in ignition on, engine off mode. Now begin the sequence. Look at a watch or clock with a second hand. Wait exactly 3 seconds from the moment the dash lights come on. Do not rush this. The ECU needs those 3 seconds to complete its power on self-test and enter standby mode before it will accept the reset command. After 3 seconds, press the accelerator pedal all the way to the floor and release it completely. Do this 5 full times in a row. Full depression, full release, full depression, full release, 5 complete cycles, all within a 5-second window. The movement should be deliberate and complete each time. Halfway does not register. The pedal position sensor needs to see the full range of travel on every cycle. After the 5th release, immediately stop and wait. Do not touch the pedal. Hold for exactly 7 seconds. After the 7-second pause, press the accelerator pedal to the floor again and hold it there. Do not release it. Keep steady. Full pressure on the pedal. After approximately 10 seconds, watch the check engine light on your dashboard. It will begin to flash. This flashing is the confirmation signal. It means the ECU has received the initialization command, recognized the sequence, and has entered its reset and relearn mode. The flash pattern is the computer telling you it is processing the command. Keep holding the pedal to the floor. Do not release it when the light starts flashing. Continue to hold for another 10 seconds until the check engine light stops flashing and holds steady. The moment it goes solid, release the accelerator pedal completely. Turn the ignition off. Remove your foot from everything. Sit quietly for 60 full seconds. This waiting period is not optional. The ECU needs that time to complete the memory clear, write the blank adaptive tables back to non-volatile storage, and shut down all systems cleanly. If you start the car before this process is complete, you interrupt the write cycle and the reset does not take full effect. After 60 seconds, start the engine normally and drive. For the first 15 to 20 minutes of driving, the ECU is building a completely fresh baseline. It has no learned data. It is operating on pure factory calibration. Drive normally, including a mix of city and highway if possible, to give the system a clean initial sample to work from. You will feel the difference from the first acceleration. The hesitation gap at the top of the pedal will be gone. The engine will pull through the rev range without the soft, uncertain feeling that accumulated over thousands of miles of adaptive learning. The transmission will respond more crisply to throttle inputs because the shift logic is also part of the adaptive system that was just cleared. Your car is running the same software it shipped with: clean, direct, and immediate. This is not a placebo. This is not a trick of perception. The adaptive learning tables that were cleared had measurably altered the input-to-output relationship between your pedal and your throttle plate. Removing those tables restores the factory mapping. The response you feel is the response that was always there, underneath everything the computer had learned to work around. The service industry built a revenue line around the fact that you did not know this existed. A $150 diagnostic line item that represents 2 minutes of work and 0 parts, multiplied across every driver who comes in complaining about a sluggish engine, multiplied across every dealership in the country. It is not a conspiracy. It is just information asymmetry. They knew something you did not, and they charged you for the gap. Now the gap is closed. Perform this sequence every 15,000 miles as part of your regular maintenance, and your engine will respond like new throughout its service life. Share this with every driver you know who has complained about throttle lag, hesitation, or a car that just does not feel as fast as it used to. Because the fix has always been free. It has always been fast. And it has always been sitting right there in your car, waiting for you to use it.